Hello, everyone, and thank you all for joining this very special first DevSecCon Australia. How was that intro? That intro was amazing. Such catchy tune too. Anyway, I hope you all had a really good holiday break. And well, it's never too. Is it too late to say it? Anyway, it's not too late to say it. But Happy New Year and welcome to 2022. A whole new year. How awesome is that? Whole new time to be able to learn things, connect with new people. And well, just as always, geek out and have fun because, well, that's what it's all about, right? Anyway, for those that don't know, we're the DevSecCon, and in particular this chapter. And like I said at the start, this is the first ever meetup for DevSecCon Australia. But DevSecCon is a chapter of the global DevSecCon community, which is an inclusive community that educates and enables developers in application security. And again, it's all about geeking out, having fun, learning new things, and sharing what you know. This is the open source way. Before we get underway, I'd like to begin by acknowledging and paying my respects to the traditional owners on the lands on which we meet today, with a special heartfelt acknowledgement and respect to the Wurundjeri people, who are the traditional owners on the lands that I'm presenting from today in central west New South Wales. I'd also like to pay my respects and acknowledgement to Indigenous elders, past, present, and emerging. So coming up, we're going to be hearing from the amazing Aaron Robertson, who is an ecosystem engineer, talking about secrets management using HashiCorp Vault. Now, this was one of my, no pressure to Aaron, who is currently backstage. He will be coming up in a minute, but no pressure, Aaron. But this was one of my favorite talks from 2021. So really excited to have Aaron talking today and sharing some of these stories and the journey into implementing secrets management, because, wow, it's a really cool talk, but I'm not going to keep putting more pressure on poor Aaron. Before we dive into that, I just wanted to quickly introduce myself. So for those that don't know me, hello, and as it says at the bottom of the screen, hello, my name is Developer Steve. I'm one of the senior developer advocates at Snyk. Love geeking out with different communities, just again, as is the open source way, learning new things, sharing what I know, and just geeking out because it's fun. I know I keep saying that, but I mean, that's what open source is, right? Anyway, we do love feedback. So there is a Discord. Let me get the link handy. I did have a link. There it is. I'm going to put the link up on the screen and I'll pop it into the chat as well. So if you haven't yet joined the Discord, there we go there. Please join us on Discord to, well, ask questions for our speakers, request talks, give us feedback, just chat with folks and just to be able to connect because, well, it's loads of fun to do so. But also, yeah, Discord is a great place to be able to connect to the DevSecCon community and well, just be able to geek out again. But it's totally the best place to interact with speakers and community. And we have some fun events planned for the year. I don't want to give too much away yet. Stay tuned for that. But Discord's a place that you are able to, well, find out stuff quicker, sooner, and just be able to chat all things DevSecOps, apps, and all sorts of different things with the different community groups inside there. So check that out and sign up. If you're listening to this session after the live recording, hello from the past. But also you can still ask questions in the Discord and be able to connect to people. Our speakers are in there as well, so you can reach out to them easier, or we'll put up the links for their various social media platforms as well, so you can connect to them as well. So DevSecCon is brought to you by Snyk, and our aim is to create a vendor-neutral space to share knowledge and best practices related to software security. Again, it's very open source sort of approach in that we're all here to learn stuff and geek out and connect, which is really, really cool. Anyway, that's enough for me. Without further ado, I'm going to bring up Aaron and welcome Aaron to the virtual session. Let me do some magic here. Hello, Aaron.
Hello, how do we do?
Hello, and thank you very much for joining us. Also, Happy New Year.
Yes, Happy New Year to you too, and thanks for having me today. When Steve asked me to do this, I didn't realize this would be kicking off the very first DevSecCon meetup event, so very fun to find that out, but happy to be here.
No, thank you. Thank you for presenting. And I mean, I've already added so much pressure with this is one of my best talks in 2021. But to throw on top of that, the fact that this is the very first one. So, so much pressure. So much pressure.
Yeah.
But you'll do fine. You'll do fine. Pressure makes diamonds, right?
Yeah, sure. Looking forward to coming away from this with a few extra diamonds.
All right, let me bring up the presentation mode, put your screen on. Now, as we're going, like I said, please jump into the Discord. If you're already in there as well, you can ask questions in there. I'll be monitoring that, and also on our YouTube channel. So if you're watching on YouTube, you can put questions in Discord or into the YouTube chat, and we'll get to those at the end. So anyway, that's enough for me. I'll hand over to you, Aaron.
Ooh. Thank you. Put this guy over here. All right, let's go. So today we're going to be talking about secrets management and our journey with Vault. So a little bit about myself. I'm currently a security engineer at Atlassian on the ecosystem security team. It's my team's job to basically secure all of the platforms that are behind or third-party add-ons, extensions, and on the Atlassian marketplace, and how they integrate with all of our core products and stuff. So the content from this talk, however, is from a previous job that I had at a large Australian retail company. And you can find me around the online under hotfix. So the game plan today is I'll start off with some fundamental information and then talk a little bit about the reasons behind why we ended up going down the Vault road. Talk about the architecture we ended up going with and how we built that out in AWS. Then touch on a few of the main concepts and features of Vault that might be interesting. And then we'll get into two use cases that we implemented with Vault. If you do some Googling, it's really easy to find like plenty of well-documented examples of integrating Vault with things that support Vault or vice versa. But so I thought today maybe we'll just talk about two fairly non-standard use cases that we faced. The first one is the big initial challenge that we decided would be our proof of concept for Vault, which was getting it to work with our very critical legacy databases that don't support anything from this century. And then secondly, an extension on that project where we were able to use that same process that we kind of ended up with to add some extra features and make people's lives easier. Cool, let's get into it. So I assume we all know what a secret is, but security policy and generally security policy will always say to store them securely or encrypt them and put them somewhere that they're safe. But this can be much easier said than done, especially when you factor in systems that need to retrieve secrets without any human interaction, like CI/CD deployments, CI/CD pipelines, deployments, scheduled scripts, and applications running in basically any application running in any environment will need to have automatic access to a secret. Worrying about access control as well, so making sure only the right entities can access the right secrets. Rotation of secrets can be an absolute nightmare, and realistically, rotation has to be automatic as well for it to be really feasible. And auditability as well, so being able to tell who is using secrets and when, and that's all very tough. All of which were problems that we had at the time. So some of the main issues we were facing was we had no standardized process for how people should handle secrets, which means that they end up literally everywhere. You find them in source code repositories, you find them in wiki pages, you find plain text secrets scattered all over the business. Even people that are trying to do the right thing will go store their secrets in password safes, but they're just completely random, undocumented password safes that nobody knows about, and one person has the password too, and if that person leaves, then it can be just as much trouble as if you were storing them in plain text. Rotating secrets is very hard and very scary. in our case, it was nearly impossible to rotate database passwords without some downtime. And depending on how many secrets you need to rotate, this could mean some very long overnight change windows for lots of people to rotate things over and test that everything works, with an outage window, which is nobody wants to do. Pretty much none of our applications or platforms supported rotating secrets natively. And luckily we didn't ever run into this, but there was always the risk of, if secret rotating does go wrong, it could mean some even worse downtime or even data loss in the worst case scenario. So we were very Kubernetes heavy. Pretty much all of our microservices were running in Kubernetes, and all of the Kubernetes configuration for pods that are deployed to Kubernetes are defined as code in Helm charts in the Git repository alongside the application. With no real good way to pass these secrets into these Helm chart configurations or into these pods, it means that there were pretty much just plain text secrets that the applications needed stored in the Helm charts and with it in the Git repo. And we didn't really advise using Kubernetes secrets at the time. I'm not sure if this has advanced much in the last few years, but at the time, Kubernetes secrets were essentially just base64 encoded. They weren't really securely encrypted at all. And of course, there's this critical legacy database that pretty much all of the production services are dependent on. So we started off by doing a little bit of a market evaluation to see what was out there and compare a few pairs. We looked at 3 solutions on the market. So some of the main requirements that we had during this evaluation was that microservices needed to be able to automatically retrieve their secrets. It needed to have good integration with Kubernetes or some good way to solve our Kubernetes secret problem. It also would be very good if it supported AWS, GCP, and Azure, because we had a production presence in all 3. Thorough API to allow automation. Obviously, automatic secret rotation is a big must. And goes without saying, for a platform this critical, it needs to be highly available, and disaster recovery needs to be very reliable. Another key requirement that probably pushed us down towards the Vault path off the bat was that ideally it would need to have no or low upfront cost commitments to actually use the product or platform. Since this project, it was started off as just a small proof of concept. It hadn't yet been accepted widely as something that we want or need. So this project really had to start small, prove its value, and then grow from there before we could actually seek more funding. And of course, there's not much point in us implementing a secrets management platform if it doesn't play well with these databases. So some of the big pros for going down the Vault road, it is fairly cloud agnostic. Since Vault itself is, it's like a core platform that does the secrets management and various things, and there's modules that are added to Vault which integrate with certain things. There was a module for each of the 3 cloud providers, which looked pretty good. There are some pretty big name enterprises that have been using Vault for quite a long time and seem to still want to use Vault, so that gave us a bit of confidence as well. The Terraform provider, which you can use to configure Vault itself, which I'll get into later, it's when you start to use it, it's very clear that it was built as an API server first, and then they added a CLI, GUI, and SDKs around it. So that was really good to know that the API will always support everything you ever need to do in Vault. The self-managed open source option is awesome. So it pretty much, the open source tier pretty much ticked all of the boxes for what we would need out of Vault, even on a long term. So that was a really big plus. It was pretty much like when we kicked off the project, it was really easy to say, this isn't going to cost you anything except the EC2 instances and man hours. So that was great to get this off the ground. And to this day, I believe they're still not paying any licensing costs, and they're still on the open source model in production. The auditability is pretty good. You get really, really granular audit logs out of Vault for everything that ever touches the API. Has heaps of integrations with all kinds of platforms and software, and the highly available deployment looked pretty good. So onto the architecture we landed with. We wanted to make it as GitOps as possible and as automated for the deployment and configuration as we could. So that was kind of one of the driving design things. We went with 3 standalone clusters. Dev was our, just sandbox, test, destroy, blow up, restore, play around cluster. Non-prod would support all non-prod or pre-prod applications. So that meant for us, we kind of had to treat that as if it was a production cluster, but obviously a lot less risky if something goes wrong with that cluster. And then prod is for prod. Decided to use the KMS auto unseal feature. So with Vault, all of the secrets that are stored to disk are encrypted. So that means in order for Vault to work, it has to decrypt everything on startup, keep it in memory, and that's how it can actually function. So when a Vault node starts up, you have to unseal it with some crypto keys, which would be a nightmare for the design we were going for with nodes constantly spinning up and down. So the auto unseal option is really, really neat because you can basically hand that off to KMS, ensure that the EC2 instances have permission to use the KMS key, and it'll just automatically unseal by itself. We're going for open source deployment on EC2 instances, and CloudFormation would be used for all of the AWS infrastructure, and Ansible would be used for actually configuring the EC2 nodes once they start up. And we really wanted to treat these EC2 instances as if they were really like ephemeral, almost containers themselves. So that was kind of part of how we approached it. This is the reference architecture HashiCorp gives you, at least for the design we were going for. So I'm not sure if you can see my mouse cursor. So we have 5 console nodes that make a highly available cluster for the storage backend. And then we have a Vault node in each availability zone. And a console client runs on each Vault node. So these console clients are hooked up to the whole cluster. They talk to the console servers and the other console clients, and they're all aware of each other. And the Vault nodes just need to talk to console over localhost. So that kind of works quite nicely. Console is pretty smart in how it handles cluster stuff and communication. So yeah, and so HTTP traffic comes in and hits the Vault nodes. So as for our AWS infrastructure that we ended up with, there was obviously some proof of concept playing around in testing, but this is how we ended up when it was finally ready in production and people started using it. So we started off with creating a KMS key in our AWS root account, which should pretty much never be accessed by any human ever, and is super locked down. So we thought this would be a really, really good place to put the KMS key. Now in our security account, we created an IAM role, which has cross-account access to use encrypt, decrypt on that KMS key, which will be how we get our nodes to actually be able to use it. Off to the side, we have a stack just for some configuration stuff. So we have an S3 bucket, which contains everything that the nodes will need to configure themselves. So Ansible playbooks live here, as well as Let's Encrypt certificates for TLS. And just to ensure that those certificates are always valid, we've got a Lambda function off to the side on a schedule, which picks them up, renews them if they need to be by hitting Route 53 and plonking it back in the bucket. As for the compute, it looked like this. So we have an application load balancer, which accepts traffic in on 443. That traffic gets load balanced across to the Vault nodes, an auto-scaling group of Vault nodes. And those Vault nodes talk to an auto-scaling group of 5 console nodes. A load balancer does health checking across both auto-scaling groups. So if any node ever stops starts failing health checks, auto scaling will kill off that node and start up a new one and try to replace it to make sure it's nice and healthy. There's also some parameters that you need as well to join a console cluster. So those are stored as encrypted strings in system manager parameters. All in all, this is what we ended up with for each Vault cluster. There's some extra stuff off to the side as well. There's an SQS queue looking for lifecycle hooks, lifecycle hook messages, which we'll talk about in a sec, and we have backups as well. So yeah, I just want to have a slide to talk about rolling replacements because it's super cool and served us really, really well. If you haven't used auto scaling groups in AWS before, rolling replacements is awesome as a deployment strategy. So what this means is every EC2 instance, we set up every EC2 instance to be listening to this SQS queue for messages that say to terminate itself. When it does see a message that says to terminate for itself, before actually terminating, first it'll gracefully leave. So in console's instance, first it will gracefully leave the console cluster so the other nodes don't freak out. Then auto scaling will start a new node to replace it. That Ansible on that node will configure itself. It'll join the cluster. When that signals that it's joined and healthy to ready to go, then that old node gets killed off and it moves on to the next one and slowly works its way through all 8 nodes in the clusters. So this is awesome because it means zero downtime, essentially almost zero downtime during deployments. We did have typically see a 1 to 2 second downtime when the Vault node that was the master or active node is switched to another node. There was like 1 second of downtime where they did that switch over. But since pretty much all of our Vault clients that are hitting it know they have like built-in logic to retry if a request to Vault fails, this means that we have practically zero downtime during deployments. So we were able to do production deployments nonstop all day, even during our busiest business hours, which is great coming from a team that used to look after stuff where you have to schedule. If you want to change something, you have to schedule like 4-hour outage windows in the middle of the night. So this was really, really cool. As for the disaster recovery side, we had an hourly job on the console nodes, which would first check whether or not it's the master. And if it is the master, it'll do a console snapshot. It drops this into an S3 bucket, which has a 30-day object lock on it, which means if any file is written to the bucket, no matter what, nobody can delete that file for 30 days, which should give us some assurance in case, say, you get ransomware or something, or somebody's really trying to destroy Vault and delete all the backups. We also had a Lambda function as well, which when a backup does get dropped in the bucket, the Lambda function would pick up that backup file and do some validation just to make sure that the backup is legit, that it seems all good. And since console is just really like a big key value storage thing, that Lambda could actually unpack the zip, untar the tar archive and look through the key value structure to make sure that the backup file is actually valid, which was really awesome. And then, we had a 90-day transition to Glacier storage on that bucket as well. So as for restoring from the backup, we made the CloudFormation templates and the Ansible playbooks able to basically do the full restore process itself, which would mean in order to completely restore the cluster or the state of both clusters from backup, assuming everything is destroyed and it's completely blown away, in order to restore from a point-in-time backup, we just have to run a manual CloudFormation deployment of the stack and provide a couple of extra parameters, one of them being which snapshot you want to restore from in the bucket. Auto scaling does a will replace deployment, which means rather than doing that one-by-one rolling deployment, it'll just bring up 8 full fresh nodes at the same time and then throw away whatever is left on the other side. Once these nodes are brought up, console nodes they'll boot up, they'll connect to each other and do their thing and elect a leader. That leader, once it's selected, that leader will download the backup file from S3, restore the cluster from that, and then boom, you've got a nice, fresh, new working Vault and console cluster, exactly in the state that it was on the time that the snapshot was taken. Luckily, we never really had to use this in production, but definitely in the dev cluster, this was a really, really handy process whenever we're testing something crazy or blew something up and just completely nuked it. It was so easy to just completely restore from backup, which is also good, I guess, because it's not often you get to actually test your disaster recovery. So being able to test it every week or two is pretty good too. Enough about architecture and stuff. How does Vault actually work if you haven't used it before? So 4 of the main concepts we need to get a handle on today are authentication methods. This is how human or machine entities authenticate to Vault using various methods. When you do authenticate to Vault successfully, it returns a Vault token, which looks like this on the right, this string that starts with an s.h, blah, blah, blah. You provide this token in a header on requests back to Vault when you're calling for resources and stuff, and Vault will do your thing. The cool thing about tokens is that there's a couple of different restrictions that you can set on tokens under different scenarios, which allows for a lot of flexibility. You can set certain time to lives on tokens so that it'll only be valid for X number of minutes. You can set max number of uses on tokens. So there were a couple of times where we had scenarios where we only wanted to spit out single-use tokens, which is really, really cool. You can also IP restrict where the token can be used from, which we made heavy use of as well. So Vault will check if there is an IP restriction. Vault, when Vault gets a token along with a request, it'll check whether the source IP address of the request is whitelisted within the range, and if not, it'll just ignore it. Policies are basically just a list of permission that define what something can do in Vault, very similar to like IAM policies in the cloud. And so when a Vault token is minted, 1 or more policies will be attached to that token, like you can see on the right. Secrets engines are pretty much what we're really looking for out of Vault. They are the modules that store, generate, or encrypt data. And there are many supported integrations that exist out of the box, since it's all pretty open source and the community has written lots of modules and integrations that have then been taken on by HashiCorp and maintained and made part of the whole product. But as we'll see a little bit later, this means you can, since it's all open source, you can write or customize your own plugins to do whatever you need. So this is what a policy looks like. They're all written in HCL, which stands for HashiCorp Configuration Language. So everything in Vault exists at a URL-like path, which mostly aligns with the path that you'd hit on the REST API, which is nice. So say something like this, secret foo, we're going to create a permission that allows reading that. The capabilities that you can set on each path, read, write, create, delete, they align directly to the REST methods that the HTTP methods that you use when you hit the REST API. So get, put, post, delete. And it also has fairly decent flexibility when it comes to wildcarding and templating in your paths as well, which can be really handy when you're writing policies. So it looks a little bit hairy, but stick with me. This is one of the main features that really appealed to us, was how the Kubernetes authentication method worked. How it works is I'm not sure if you can see my cursor. Oh, yeah, I think you can. That's good. So the way it works is when you deploy a container in a pod to Kubernetes, it will bind to a Kubernetes service account. by default, this is just the default service account, but you can create and bind to your own custom service accounts. When a pod starts up, like a signed JWT token is created and stored in a path on the file system in the pod. And that JWT token contains some interesting data. The way that this auth method works is when the container starts up, it picks up this JWT token, which is stored automatically inside it. It passes that to Vault and says, hey, I want to authenticate as this token. Vault then hits the Kubernetes API, passing the token, saying, hey, verify this token and give me more metadata about the token. Kubernetes returns some information, which we will use to determine what this should be allowed to access. So the service account name and namespaces are one of them. Vault then checks this against its internal policy to see what this should be allowed to access. And that essentially authenticates this pod. It then returns a Vault token, and we're in. We've authenticated to Vault. Then using that Vault token, this pod can pass that along and say, hey, give me secrets, or let me write secrets, or whatever it's trying to do. And that's it. You're in. You're done. This was really, really neat, and didn't really see anything that solved this problem in quite a neat way. And after playing around with it, the team that manages the Kubernetes clusters actually really, really liked it. So that was a big green light for us. This effectively means that we were able to shift the risk from our secrets being stored in plain text and Helm charts in Git to the question of whether or not your pod in Kubernetes is allowed to bind to a certain service account in Kubernetes. By using like some Kubernetes policies to enforce which service accounts are allowed to be mounted and by which pods, and monitoring those API events for when a service account is mounted by a pod, this lets us basically do identity-based access to Vault in Kubernetes and gives us even an extra level of auditability as well. Yeah, so that was neat. Honorable mention also goes to the app role authentication method. This is kind of, we basically treated this as our fallback auth method. If none of the other auth methods are supported by what's trying to integrate with Vault or will work, this is what we'd be falling back on. When you create an app role, to authenticate using that role, you have a role ID and a secret ID, which is essentially just a username and a password. You might think, how's that any more secure than just using a username password if you're going to be keeping the static long-lived secret anyway? I think the key for us was really the restrictions that you can put on the tokens. You can also put most of these restrictions on the secret IDs. So in the case for old servers, which always live behind a static IP address and never really change, this was really handy because we can we can whitelist just that IP. So even if the secret ID gets leaked or the resulting Vault token after authentication gets leaked, they will be invalid unless the source IP address is the host that is allowed to use it, which allowed us to tighten a lot of security for a lot of old systems that have been around for a very long time, and this will be quite relevant in a sec. So the key value secrets backend is really, really awesome, flexible, generic, just store whatever you want, however you want. You can store secrets recursively under a path, under the key value engine, and each secret can have any number of key value pairs as well. There are also some cool features around versioning. You can configure it so that it keeps X number of versions of a secret in case, say, somebody overwrites it by accident or deletes it by accident. And you can set it so, and like the policies can be so granular. The way we had it configured was so Vault admins can see the last 10 versions of a secret, but non-admins can only see the current version of the secret. So yeah, it can be quite flexible, which is very nice. A little bit about the Terraform. If you're not familiar with Terraform, it's basically a tool for managing infrastructure as code. It's also built and maintained by HashiCorp, but there is a provider that Terraform has which actually allows you to configure Vault itself. And after playing around with this for a while, we made the decision to only configure Vault using Terraform. So everything would, all of the configuration of the platform itself would be managed as code. The Terraform provider supports almost all Vault resources. There were a few that were not supported at the time when I was trying to use it, but they also do provide generic API Terraform resources that you can use to just hit the REST API directly in your Terraform objects, which allows you to get around any of these use cases until it is actually supported. Then you can move over to that. Really awesome pros of Terraform is obviously it's code or code-like, so you can do templating, you can make reusable modules, you can loop over lists of resources to make stuff, you can do conditional statements for stuff that gets made. So it's automation galore. However, big con is that in my opinion, Terraform syntax is super jank, especially if you're trying to, like, the more complex stuff you're trying to do, the more issues you're going to run into with Terraform syntax. So not saying it's not usable, I'm just saying it's a big learning curve to pick up. You might have to do I kind of wish I did a little Terraform course before I actually started this project, because it led to a lot of frustration, but it all worked in the end. Some of the benefits of taking this approach means that we can do automated testing for every single change that's ever made. Because it's all managed in Git, we have a full history of all changes that are ever made to Vault, and it's pretty easy to roll back if bad changes are made. It allows dev teams to self-service their Vault configuration for their apps, which we had seemed like a lot of teams really enjoyed. Teams, rather than just approaching us or logging a ticket, teams who decide they actually want to play around with the Terraform, they can request permissions, more or less permissions or changes with a pull request, and as security, we can just review that for them. It takes a lot of pressure off vaulted admins if people are starting to try and self-manage their own configuration. But we also had a lot of really good feedback, and a lot of devs responded really well to being given access and transparency to this security platform that their apps critically rely on. Yeah, so the reusable modules in Terraform was really, really awesome, because we can configure, for a single use case, we can configure the resources the way that we want them to be configured. And we can just say to the teams here, consume this module. So call this and pass in the parameters that you need for whatever it is you're trying to do. And it also means if we want to tweak the best practice, we can just do it in one place, and that'll be rolled out to everyone's configs. This whole approach just really encourages a lot of the dev teams to understand Vault better as well, and understand how their apps interact with it. So it kind of just gives everyone a wider ownership of the platform, rather than just saying, okay, that's security's platform, if something's broken, they'll fix it. When things actually did break, we had a lot of people jumping on and piling on to try and fix it together, which was really sweet. So this is what a typical change would look like. Somebody who's making a change to the Terraform configuration would raise a pull request with the change they want to make. That'll kick off a build. CI/CD would lint all the scripts and Terraform and stuff, but it would also launch some pretty thorough integration testing as well. So it would spin up a Vault container, and it would also spin up a container for each platform that Vault is integrated with. So MySQLDB, MongoDB, Postgres, and a Samba DC container to simulate Active Directory. It would create all of the users in Active Directory that are expected to be there, and if there are other required users, it'll go create those in those platforms. Like Elasticsearch was one that needed a whole bunch of like startup config, so it would do all that. And then it would apply this Terraform it would apply the Terraform to the Vault container and actually let everything work. So and set it up pretty much as if it was going to be run like as production would be set up, obviously without any of the actual secrets in it. What this means is that if a build comes back green for a Vault PR, we can have a really high degree of confidence that this change is going to work, at least on a basic level, and is syntactically correct. It doesn't have any clashes or whatever. So as a Vault admin, all you really have to do is just make sure that the PR isn't going to be breaking anything obvious or really crazy. At least you know that it's going to work on a base level. Approve the PR, merges PR, that gets applied to Vault, and everyone's happy. So time for a sip. First challenge was this beautiful old crusty legacy database. This database was pretty old, and the operating system that it was running on was even older. Obviously doesn't integrate with anything recent. Even HashiCorp engineers in an intro meeting we had quite a while before kicking off this project were like, yeah, this is going to require a lot of custom work to get working. So we thought, we should probably check out how this would work, if we can make it work. We ended up just, there's hard-coded, very old passwords, very, very difficult to rotate, manually rotating prod passwords guarantees downtime, which is not ideal. This was midway through a several-year ongoing migration from the old database software on this old Unix operating system to much newer database software running on the latest Linux operating systems. So this migration was going on for a long time, but as you'll see in a sec, it introduced a whole bunch of different challenges. Inconsistent usernaming standards. There's a 8-character limit on usernames on this operating system, and it's been that way for many, many years, and lots of users have been created over that time. So it's also really, really hard to meaningfully convey what a user is for in just 8 characters. So there's a lot of garbage sounding users that exist. And DBAs frequently have to ping people in Slack asking whose application is using this username so we can troubleshoot this issue. Really not ideal. Dev teams are already generally very busy delivering new features and already have heaps of stuff that they have to maintain and look after. So a key criteria for this is that onboarding apps to use Vault has to be as easy and seamless as humanly possible. All of these problems stacked up, we decided that this project would, this use case would be the success criteria for our initial POC with Vault. Logic being, if Vault can do this hairy problem, then it'll be fine integrating with modern stuff that actually support it. So given that this is going still in the middle of an ongoing migration and applications are slowly being migrated over bit by bit, our solution has to support both platforms transparently. So on one hand, we have these very old Unix operating systems running the old databases, which actually use operating system authentication to authenticate to the database. What this means is to create a database user, you have to create a user on the OS, and then that user's password is what they use to auth to the DB. Now on the modern side, we have our latest current Linux OSs. The database uses Active Directory for authentication, so it hands off to that, which makes a lot more sense. So to create a database user in this world, you have to create an account in Active Directory, and that user's password has to be valid. So this was really the key hump to get over. Let me just quickly talk about what we couldn't use. This is how the database secrets engine works for databases like, say, MySQL, Postgres, or whatever. what you do is you give Vault a user on the database, which has permission to create and delete users in the database. As an application, I hit Vault saying, hey, I want credentials to connect to the database. Vault then goes and creates a new user in the database with a strong random password and grants that user the permission that it should have on the database. Then that returns the credentials back to the app, and the app uses those creds, and everyone's happy. Credentials are set with a time to live. So Vault keeps track of the TTL. Once this 1 hour TTL is hit, Vault goes back and deletes that user in the database, thereby revoking the credentials. And it works pretty well once you convince database owners to give you access to create and delete users in their database automatically. Some of the benefits is that there is no clashing between shared credentials. So every app is using a different set of credentials for a different user. When an app's credentials expire and if they aren't renewed, that app just hits Vault again, gets a new user password, throws away the old one, and carries on doing its thing. So very cool. Also lets us configure really granular database permissions per application in code. So since we had everything as Terraform for application A in the configuration for its database access, we can have the grant, the SQL grant string defined there along with it. So you can define really restrictive, really granular permissions in the DB if you want. So yeah, this pretty much guarantees short-lived credentials to the database, and if credentials do get leaked, it's only until the TTL expires. So you don't have to stress too much about it. However, this isn't going to work for our use case because it needs to support both old and new at the same time. We need to be, the password on the old Unix operating system has to match a password in Active Directory at the same time. We could do this if we wrote a new custom Vault plugin to do it, but we were just at the start of our Vault journey and just starting to learn how everything worked. So this seemed like a really, really daunting task. Also seems really mega sketchy to try and port this functionality over to Active Directory. There is an Active Directory secrets engine that works very differently and probably for very good reasons. Because for the old Unix OS databases, we need to actually create users on the system. This would mean that we would need to give Vault permission to potentially very destructive permissions on our very old legacy critical database servers. It would essentially need root remote access to all of our most critical production servers. And it would be automatically deleting and creating system users on those servers, which seemed terrifying. So we just tabled this idea and decided not to go down that road. What we did end up going with, the first brainwave kind of came when a colleague reminded us that the key value secrets backend can store any number of key value pairs, not just passwords. So what we can do is store the username and a password that a service should use. We have an hourly rotation with two alternating users per service. We started off with hourly just to get like faster feedback and test whether the process would work under like a period that's way faster than necessary. We would use the Active Secrets and the Active Directory secrets engine to rotate the account password in Active Directory. And then we would sync that password down to the Unix server. So the password is valid on both, and it doesn't matter which one the app is connecting to, the creds will just work. The whole point of the alternating users is just so we can avoid a race condition where an app checks in for a password as it gets rotated and it all breaks. So in this case, as long as an application checks in with Vault quicker than an hour to get new credentials, it'll always be on the latest one. So to kick off this whole process, we started by building out a manifest of users that should be created for the databases. This manifest defines which users belong to which applications, which didn't exist before. And since we're writing it in YAML, this is a machine readable file that can be read by scripts, by engineers, and by DBAs to look things up. So we would consume this to create all of the users that should exist in Active Directory. We'll also consume this to create the users that should exist on the Linux OS, on the old Unix OS. And this will also be imported by Terraform. And Terraform will parse this YAML file. It will loop over all of the users that should exist and create all of the configuration in Vault that they need. So this file really drives the whole process. And this lives in Git, so when a new application is being onboarded, it's as simple as a pull request that we then verify and approve, and then that will go and create everything. So each legacy database server would have a shell script that is run on a cron schedule, starting off at an hour. Unfortunately, the script had to be written in Corn Shell, which I didn't even know existed before this project, but that was very interesting to have to work through. And the script, as well as the app role secret that the script would use to authenticate to Vault, is stored in the root cron tab on the server. Logic being, if you already make it to root privilege on the production database server, you already have access to what Vault is trying to protect from anyway, so it kind of makes sense to be able to store it there. The cron tab script, the cron tab command will also verify the hash of the shell script first before execution, just in case anyone tries to modify the script to do something nasty. So here's what it does. Oh yeah, and also the app role secret and the resulting Vault token are IP restricted in Vault to only be valid for this one IP address of the host. So if it gets leaked elsewhere, it should be useless. So what the script does every hour, it authenticates to Vault, it grabs that YAML manifest of users and makes sure that it creates the users locally. For each pair of users, so that's the A and B user for each application, it selects the one that has the oldest system password. So in this case, let's just say user B. It then requests a new password for that user in Active Directory because there is a user that has the exact same username in AD. Active Directory secrets engine rotates the password in AD and returns a new one. And then we set that password on the local host for that local user. Then last step, we go and update the Vault key value store for that application saying, this is your new username and password, use user B with this password. Next decision we had to make was where we're going to actually add the Vault logic so applications know how to do this. There is a HashiCorp published container that's meant to be used as a sidecar in Kubernetes to do this all for you. But after playing around with it, we realized we would still, even to use this, we would still have to make a couple of code changes. The sidecar only supports writing the secret to disk, and the application has to read it from disk. So we would have to rewrite to make applications able to do this. We'd also have to make applications be able to override their existing database configuration with new credentials, because currently they just did it once on startup and that was it. And this would have to be continually updated with new creds. And also some logic to retry on cred failure. So if it tries to connect to the database and fails, it should go ask Vault for new creds first, then try to use those to reconnect. Luckily for me, though, pretty much all of our services were written in either Python or Java, and they all used a common internal private libraries that handled the database connection logic. So the decision was made that basically we would update these internal libraries with all of the Vault logic to be able to handle this. And then people would basically just be able to update their dependency, add some configuration, and it should just be good to go. So this hairy diagram is what we end up with. just starting off as a developer. So say I want to onboard my application to use this process. All I have to do is raise a pull request to request new database users for my application. And there's a handy little script in that repo to basically take in what they want and then plonk the right user in the right format in the right file for them so they don't have to worry. So raise that pull request. Once that's merged, I need to update the dependencies, the database dependency in my application to the version that supports Vault, add a couple of Vault configuration variables to make it work, and then redeploy it. And that's it. What happens on the behind the scenes is we have this YAML manifest of all the database users that should exist. There's a pod which reads this user manifest in and makes sure that these users are created in Active Directory. Terraform also reads in this list of users, loops over them, and creates all of the configuration in Vault that's required. Then we have the shell script on the legacy database server. When it spins up, first it authors to Vault. It reads in this list of database users and ensures that they exist locally. It requests a new password for the user that is trying to rotate from Vault. Vault's AD secret engine rotates this user's password in Active Directory, returns it back here. We set that password locally, and then we store that username password in the key value store, which makes it active essentially. From that point, when an application requests credentials, it'll pick up that username password from the key value store. It'll use those creds to log into the database, and it doesn't matter which database it's logging into, those credentials will always be valid. So yeah, this is where we ended up. And this process worked really, really well. So well, in fact, I believe it is still on that hourly cron schedule and hasn't really had any issues with that ridiculous automatic rotation. And we also had really, really good feedback from the developers themselves with the onboarding process. So it started to be taken up really, really quickly. So end state, after this was implemented, database passwords are no longer stored insecurely. They only live for 2 hours. So even if credentials did get leaked, like they're going to be gone automatically anyway. Teams can onboard an application in less than an hour. That's including like time waiting for pull requests to get approved and merged with pretty much no code changes, just a bit of config change. DBAs now have a source of truth that they can use to actually look up what users belong to which applications. Applications, it doesn't matter whether they've been migrated across or not yet, it'll just work. And key thing, developers no longer have access to the production database passwords that their applications are using, which should never really be the case. 50 minutes, how are we going for time? I might be able to shoot through this really, really quickly and then have some time for questions. I'll just quickly blast through this last bit. This was an extension of the first problem. So initially it was an issue of the applications connecting to these old databases. But the second problem was humans actually trying to connect to these databases as themselves. So typically developers would log in as themselves. They need to do this every day for non-prod DBs so they can do development. But occasionally for prod DBs in emergencies, they might have to log in as well. Passwords are really old, passwords are really crap. People share their passwords around if they forgot them. So it's pretty much impossible to actually know who's logging into the production databases. So to the rescue was this service account checkout feature in the AD secrets engine. What it lets you do is create a library of accounts that are valid, and users can check out an account, which will borrow it, borrow that username and password. Only that user is shown the password to that account. And when that account gets checked in, either manually or when the time to live runs out, that password gets automatically rotated. So what this means is we can let people self-service access to these accounts without having to prompt anyone, and they would be short-lived and automatically rotated. However, because of our hairy problem where the account credentials have to be valid on both old and new systems, it wouldn't just work by itself out of the box. So Since we still have to do that password sync from AD down to the Unix host, luckily it's all open source. So we forked the AD secrets engine plugin from the HashiCorp repo. We added a new endpoint to the plugin, which lets us get the current password for a user. We used Vault policies to restrict usage of this endpoint to only the old Unix app roles and nothing else, not even people or Vault admins. And then we added a new shell script to these database hosts to do that password sync down. And we installed our custom new secrets engine. So the other thing is that these service accounts that people are checking out still are just random usernames that aren't tied to any person. So the last piece was we just added a new Lambda function, which on a fairly frequent schedule, it inspects the status of the library. It checks the Vault token of someone who borrowed an account and maps it to their real identity. And it records all of these checkouts in a DynamoDB table forever. And as an added bonus, if someone checks out production DB creds, we'll send an alert to Slack that everyone gets to see, which lets security know it happened, but it also kind of reminds developers that it should only be done in an emergency. And so as a somewhat modified version of the process, we end up with this. So the results, we maintained an internal tool called Vampire Squid, which is a CLI tool that lets people that basically automates and streamlines interacting with Vault and has commands for common things you need to do with Vault. So we just added a new command to this tool, which would help developers request these credentials from the library without having to really know how it works. So now devs have really easy access to short-lived credentials to access the database, way easier than actually chasing up a dev and asking for their password. Security has full auditability into who's accessing databases and when they accessed it. Once database migration is complete to the new one, we can ditch this custom forked plugin that we made and retire that and just switch over to using Active Directory properly. And we have some extra bonus added awareness when someone accesses a production database directly, which is all very cool and a huge improvement on the previous state. So just to wrap up, a couple of lessons that were learned in this journey. Console is a very powerful tool with lots of features, heaps of features we weren't using. So if you just need a highly available storage backend, I wouldn't recommend using Console. I would either look at the integrated storage version, which HashiCorp supports, or any of the other versions, any of the other supported backends that you don't have to manage as much. I really wish we'd gone with the DynamoDB storage backend, because then you just let AWS handle the storage backend. You don't care, you just consume it. You just worry about your Vault nodes. Managing Kubernetes service accounts and enforcing the policies for which service accounts can be mounted by which pods can be pretty difficult. We implemented some enforcement using our own custom internal tooling, but ideally, I think the end state probably looks like something like using OPA Gatekeeper to enforce policies at the Kubernetes API level. It's a very high risk system. Downtime and data loss, especially of Vault, is completely unacceptable and it must be treated as such. Luckily, we never had any data loss, but we did have one instance where there was some production downtime and it was very exciting to be around. For small use cases, or if you're just building in a single cloud platform and that's where everything's going to live, it will probably always be easier to just use that platform's secret storage instead of using Vault, since the integration's already there and it's already built in and it'll all just work. Vault, however, is a lot more useful for use cases where you have cross-cloud things trying to access the same secrets, or even cross-account access in the same cloud platform. But particularly useful for on-premise, obviously, which was where most of our stuff lived. Also, CI/CD and other platforms that don't have any native secrets management support, Vault is super flexible, so you can probably make it work. Finally, it isn't that people generally don't care about doing the right thing. They just want to be, they just need to be provided with a good recommended supported option to actually use. And people generally have different priorities on their plate. So a developer who's trying to get a service up and running by a due date isn't as necessarily worried about where do I put this password. They just need to make this work. So if you can provide them with a good way to do that, they'll be happy to do it. Some people will go the extra mile to do things the right way, but if they all do it differently, that can be just as bad as if they didn't do it at all. And the best way to get a solution onboarded by lots of people and be taken up is to make that solution just as easy or even easier for those people to use than to do the wrong thing. And you'll probably see a lot more people doing the right thing. Cool. That's it. We're done. I think we're done listening to me talking. Link on the left is to a blog post from my previous company where we kind of talked through some of the things that I've touched on today. So you can go read more if you want to hear it in more detail, and the slides as well on the right. Any questions?
I'm just going to say now, wait, before I do that, if anyone does have any questions, please drop them into the Discord. I'm still watching, got my eyes going everywhere, but yeah, drop it in the Discord or put it into the YouTube chat, and we'll get to them in a moment. I also have some questions, but I'm just going to say this is now, and again, no pressure, but this is now one of my favorite talks in 2022. So anyway, I was going to do a standing round of applause because I can now. I've got a few studios. All right, thank you, George, watching along on YouTube, saying awesome talk, and I totally agree because there was so much in that. So much so I made notes as well. So again, if you've got questions, drop them in one of the chats and we'll get to them in a sec. Wait, so you're saying base 64 isn't secure? I already know the answer to this. It was from the start when you said it. Being a PHP dev from back in the day, like it was anyway.
I definitely support base 64 encryption, but not for the most secret things.
No, that is fair. So one question I do have, if you could do one thing different throughout all that, I think you kind of touched on a few things, including getting some training in Terraform, what would it be? And I did make note of the Terraform thing. And that's totally good answer too, if you want to use that.
I think just based on the total volume of pain, it would be, I would have avoided using console. Console works and is really, really good, but there's a lot of overhead, and we just had so many troubleshooting issues that we kept running into when using console. And like having a cluster of 5 nodes that are all chatting together, and they can be a little bit too smart for their own good sometimes when they're trying to work out who's the leader, who's doing what's going on. I really wish we just started off with the DynamoDB storage backend, and then we just have to worry about 3 nodes, especially for all of the added Ansible stuff as well. Like Ansible in console to start up nicely and do its thing, and also handle like crazy edge cases there was a lot of time sunk into that we could have avoided.
One thing I did want to do a shout out to, because I think this is totally, it's not talked about enough, and I think it should be. And like I'm saying that as a developer, as a CTO, like as a data engineer from back in my origin story. And for this, I'm going to switch scenes. So disaster recovery testing is something which is totally not talked about enough, and like an amazing conference talk opportunity if someone wants to do it. And if you've got a talk on it already, like would love for you to come back, because I think that needs to get more airtime, because that's literally testing for the Murphy's Law scenario in my mind. And like we've all been there. It usually hits on a Friday night too, because why wouldn't it? So, and I know you mentioned it a little bit.
Actually, speaking of that, the one production Vault outage that we had that I mentioned, that happened at I think 6 a.m. on a Sunday when I was away at a security conference and nowhere near my phone or my laptop, and it was, I didn't hear about it until like 2 or 3 hours into the outage when they finally were actually able to get a hold of me and I could get to my computer and like, okay, now let's troubleshoot. So speaking of that Murphy's Law scenario, it was, that's exactly
always going to happen. Without fail. It's going to be that time you least expected. I mean, we saw that last year too with Log4j, when everyone was kind of, wrapping up the weekend. It's the end of the year. Everyone's like, we're going to go to the parties and stuff, like, yeah, Murphy's Law always strikes when you least expect it. But I think that whole disaster recovery testing is a really good topic. So anyway, just saying. And also migration between two platforms, like we've all been there. We've all been there. Having your feet in two camps, like needing to move data around and infrastructure around on the fly while a production system is running is always like trying to change the engine on a car while you were driving it, and fraught with dangers in its own right. We've been there. No, amazing talk. Thank you so much. If anyone wants to reach out, of course, you're on the DevSecCon Discord. So please reach out there or on any of your social networks as well. And we'll post links to that as well. But thank you very much for doing that amazing talk. It is totally one of my favorites from 2022, and the year is still young, so already made the show. But also an amazing talk for the first DevSecCon Australia. So thank you very much.
Thanks for having me.
So anyway, thank you all for joining us. Really hope you enjoyed that. That totally is one of my one of my favorite talks. So if you're watching this in the future, please reach out on the DevSecCon Discord. The links are all listed, so join us there and continue the chat. The next DevSecCon Australia will be in February, somewhere around the week of the 20th. We're just waiting to confirm some speakers now. So stay tuned for that. Please join the meetup if you're not already on there. Join us on the DevSecCon Discord, and we will talk to you very soon. I'm going to exit leaving with that amazing intro video that Sam in the UK helped put together. It's just really cool. I love the music and the special effects. Special effects are on par. Anyway, I'm going to leave us with that because it was just amazing to watch. So bear with me, just clicking a few buttons.